Welcome to AI Brief, episode 403. We usually talk about AI constraints in terms of chips or grid capacity,
Right.
but today the conversation is shifting. It's getting surprisingly physical.
It really is. We're moving from just code and parameters
Hmm.
to these massive infrastructure shifts.
Things like launching servers into orbit.
Or retooling entire car factories for humanoid robots.
Yeah.
And on top of that, we've got Google research with a new method called GIS, a robotics pivot at Tesla, and some big humanoid reveals.
Plus our top productivity tools at the end. It feels like the industry is hitting a literal wall of energy and space, and the solutions are starting to sound like science fiction.
Science fiction, Ed, is very quickly becoming engineering reality.
So let's start with the one that feels the most out there, SpaceX. They want to put actual AI data centers in orbit.
That's the plan. They're seeking FCC approval right now for a whole constellation of satellites.
Satellites just for AI compute.
Exactly.
Yeah.
And this isn't just a concept. They've started testing. The aim is to get the first payloads up this year.
Okay, unpack the logic for me. Why? It costs a fortune to send anything to space. Why not just build a warehouse in Texas?
It comes down to two main things: energy and heat.
Okay.
On Earth, data centers consume a staggering amount of electricity.
Ah,
They use
the-
so much water for cooling.
Right, the environmental impact is becoming a huge issue.
A massive issue. But in orbit, you have direct, unblocked access to solar energy.
24/7.
You don't need a power plant. You just need solar panels.
So the power is effectively free once you're up there.
Hmm.
What about the cooling, though? Isn't space just cold?
That's the common misconception, yeah. Space is cold, but it's a vacuum.
So there's nothing to transfer the heat to?
Precisely. A vacuum is a terrible conductor. On Earth, you have air flowing over the servers. In space, there's no air. The heat has nowhere to go unless you actively radiate it out.
You could just melt your own hardware.
That is the engineering bottleneck.
Hmm.
But if SpaceX can solve that thermal management, it completely changes the economics of AI. You remove the land cost, the energy bill, the water usage.
But surely there's a catch. Latency.
A huge catch, yes.
Yeah.
You aren't going to use these satellites to run a real-time chatbot.
The delay would be too long.
The speed of light is fast, but the distance adds up. These orbital centers would be for the big training runs, the heavy background number crunching.
So you upload the job, let it cook on solar power for a month, and then download the finished model.
That's the idea.
Uh,
And it's only possible because they own the truck that gets it there.
the Starship.
That's the linchpin. You need a heavy payload rocket for this. It's the ultimate vertical integration.
It is, but while Musk is looking for infinite energy in space, Google seems to be solving the same problem from the opposite direction.
Right. Instead of finding more power, they're trying to make the AI less hungry.
Which brings us to digest.
Exactly. This is a new paper from Google Research, presented at NeurIPS 2025. And for developers listening, this might be more immediately impactful than orbital servers.
They're tackling what people call the data wall, right?
That's it. The industry has this assumption that more data is always better.
Just feed the beast everything you can find.
But we're hitting a point where processing everything is just too expensive and too slow. We're running out of compute.
So GIST is a kind of filter.
Think of it more like a ruthless, very smart curator. It uses a greedy mathematical strategy.
Okay, I have to stop you. Greedy strategy sounds like something from finance. What does it mean for an algorithm?
It's a classic computer science term. So imagine you're packing a suitcase 5 minutes before your flight.
Right, panic mode.
You don't have time to perfectly calculate the optimal arrangement of every single item. You just grab the biggest, most important things first, the greedy choice, and stuff them in. You make the best immediate choice at every step.
You prioritize the essentials and just ignore the fluff because you don't have time.
Exactly. And GST does that with data. It rapidly selects data points that offer the best balance of diversity and utility.
Isn't that dangerous, though? If you throw away, say, 40% of your training data because an algorithm calls it fluff, aren't you worried you're tossing out the very edge cases that make a model smart?
That is always the fear. But the results from the paper are pretty surprising. They found that by pruning the data set, they didn't just save time. They actually beat the gold standard on benchmarks like image classification.
Wait, hold on. The model got smarter by learning from less data.
By learning from better data. It turns out a lot of what we feed these models is just noise. Duplicates, low-quality junk. GIST removes that.
So you get a mathematical guarantee that you're getting the best trade-off.
The best possible trade-off between the size of your data set and the quality of the information in it. It's about running leaner without getting dumber.
Which lowers the barrier to entry for everyone.
It changes the game for anyone who doesn't have a billion-dollar compute cluster.
So we have space servers for massive training and smarter math to make those runs efficient. But let's bring this back down to Earth, to the factory floor.
The Tesla news.
This one is wild. Reports are saying Tesla is killing off the Model S and the Model X.
The cars that basically put them on the map. It is the end of an era. But if you look at the financials, you can see why. Tesla just posted its first ever annual revenue decline.
Down 3% to about 95 billion.
Right. But at the same time, their capital expenditures, what they're spending on the future, is set to exceed $17 billion in 2026.
So revenue from cars is down, but they're spending more than ever. What are they buying?
They're buying their next act. They are literally clearing the factory floor space to make room for humanoid robots.
They're pivoting the entire company from electric car maker to...
Robotics and AI company.
That's a burn the ships moment, isn't it? You're cutting off your legacy products to bet the entire farm on something that, well, let's be honest, isn't fully ready yet.
It is an incredibly high-risk maneuver. They also just announced a $2 billion investment in XAI.
So Musk is consolidating all his resources.
He's betting that the market for a humanoid worker is infinitely larger than the market for a luxury sedan, which it is.
If the robot works.
If it works. And there's still a memory chip shortage, he warned, could impact their plans. So it's a race against time.
And speaking of robots, Tesla isn't the only one trying to crack this. We have updates from a couple of other players.
Right, and with very different philosophies. First, you have Fauna Robotics out of New York City. They just launched Sprout.
I saw that picture of this. It's sage green and wrapped in foam.
It's a very deliberate choice. They're targeting the home and education markets. They want it to be safe around people, around kids.
So Big Hero 6 kind of approach.
Exactly. But their business model is the interesting part. They want to be the iPhone of robots.
The developer platform.
Yes. They want other people to write the apps for Sprout. It's a canvas for developers, not a single-purpose machine. They're aiming for the same price point as China's Unitree, but betting on that software ecosystem.
Which is a sharp contrast to what Figure AI is doing.
A very sharp contrast. They just released a demo of their Helix O2 model, and they are not wrapping it in foam. They are focused on pure capability.
The dishwasher demo. We have to talk about this. The video shows the robot loading and unloading a dishwasher. To a person, that sounds incredibly boring.
It does.
So why is the robotics world going crazy over it?
Because of Moravec's paradox. In AI, things that are hard for humans, like chess, are easy for computers. But the things that are easy for us
folding laundry or loading a dishwasher
are excruciatingly hard for robots. Think about it. A plate is slippery, it's fragile, the rack slides around, the geometry is constantly changing.
So much nuance.
Figure AI claims this is the most complex manipulation task ever demonstrated by a humanoid. But the real breakthrough is how it did it.
It wasn't just programmed step by step.
No, it used a single neural network. It was trained on over 1,000 hours of human motion data. The network just maps the pixels it sees directly to the actions of its body.
It's end-to-end learning.
Yes. It figures out how to coordinate its 61 joints fluidly just by watching and learning, not by being hand-coded by an engineer.
That feels like the ChatGPT moment for physical robotics.
That is the perfect analogy. And that's why Tesla is clearing out its factory floor. Because if you can solve that, you don't just have a car factory worker. You have a worker that can do anything.
It's amazing how all these threads connect. You need the compute from orbital satellites to train the neural nets. You need algorithms like GEC to make it efficient.
And then you download that brain into a chassis from Tesla or Figure to do actual work in the world.
The entire ecosystem is forming right in front of us.
At every level.
So before we wrap up, let's talk about the tools people can actually use today.
Okay, there's a lot of movement in the utility space. The standout for me this week is Pretty Prompt 1.0.
I've heard this called Grammarly for prompting.
That is the best way to think about it. You know that feeling of staring at a blank chat box?
All the time.
You know what you want, but you don't know how to phrase it. Pretty Prompt acts as that middle layer. You type your rough idea, and it optimizes it before sending it to the AI.
A translator between human speak and machine speak.
Exactly.
Yeah.
And that's going to become more and more crucial.
What else is trending?
For travelers, there's Hera.ai. It's a travel companion app that acts as a personal local guide, generating stories about the place you're standing.
And for the power users.
Two quick ones. Claude Usage Bar. It's a simple utility that shows you how much of your Claude usage capacity you have left.
So you don't get cut off mid-workflow.
Right. And finally, Skills.sh.
Skills.sh.
Yes, it's billing itself as the Agent Skills Directory. As we move towards AI agents doing tasks for us, we'll need a way to find them. This is trying to be that directory.
It's funny, we started with satellites and ended with a usage bar. It really shows the scale of what's happening.
The infrastructure is being built at every single level, from the exosphere down to the browser extension.
So I guess the question to leave everyone with is this. If the biggest players are betting their entire companies that AI is moving from generating text to moving atoms,
A shift from software optimization to brute force physical engineering.
where does that leave the rest of us who are still just trying to write better prompts?
It means we better get comfortable with the physical world again.
Something to think about. Thanks for the deep dive today.
Always a pleasure.
We encourage you to follow the show and share it with anyone interested in AI. See you in the next episode.